Okay. Assalamu alaikum. As far as chapter 3 is concerned, what you need to study, I'm just pinpointing those material first. The first thing that you need to focus on is computer architecture. And in this, you need to know von Neumann architecture. You need to know the parts of microprocessor or CPU. Then the number of the buses and their purposes. Then you need to know the registers and their purposes. And fetch execute cycle. And one more thing that you need to know is the instruction set for a CPU. After that, what else you need to know is input and output devices, which is already easy, which you have studied in detail in your junior classes. But in this chapter, what you need to focus a lot on is the sensors and their working, how sensors are used in different controlling and monitoring applications. And then a very important topic is data storage. That is divided into primary storage and secondary storage, and virtual memories and cloud storage as well. And lastly, it's your network hardware that includes your routers and your NICs and a few terms that are linked with their use as well. Now let's start with von Neumann. What is it actually and why was it needed? It wasn't there earlier, then it became now the very first thing that you need to know is CPU, also known as microprocessor or processor. It is central to all modern computer systems, and even the tablets and the smartphones who have the CPU, they do have that processor in them. It is installed as an IC on a single microprocessor chip, and CPU has been divided into main three parts, which are control unit, CU, ALU, arithmetic logic unit, arithmetic and logic unit somewhere also, it's also written, and registers and buses. The first thing is von Neumann architecture and why was it being used? In the beginning, when computers were introduced, it was all based on binary zeros and ones. And it was too difficult. The people had to be all the time active to get the task done. So John von Neumann in 1940s developed the idea of a stored program. He developed the concept, and he had proposed the idea that the computer system should be based on certain things which are going to relieve the person, and he should be working on other stuff. And he developed the idea of a CPU, central processing unit. He was the one that he's proposed that CPU was able to access the memory directly. Computer memories should not be storage, should now store programs as well as data. And be clear that programs and data are two different things. And stored programs were able to make use of instructions which could be executed in a sequential order, or actually it was a program. Before that, everything was like people were working on them. After that, what you need to know in this chapter is the components of CPU, which are ALU. What is the ALU doing? It is basically arithmetic and logic unit, and as the name implies, it can perform arithmetic, which are addition, subtraction, multiplication, and division, and logic operations as well. Basically, division and multiplication are the extended applications of addition and subtraction. It should also be able to perform logic operations, which is and or not is also included. And this is something which is not present in a calculator. Logic operation is missing, and that is why we can only perform arithmetic operations in a calculator, not the logic operations in a calculator. So now the next thing is what you need to know is control unit, CU. And its job is to read an instruction from the memory. The address of the instruction is going to be stored in PC program counter. And that is what you need to know definitely for your own reason. For your own working, the role of different buses. The control unit is doing what? It is actually meant to take care of everything happening in the CPU, and it is ensuring that synchronization of data is taking place and the instructions are followed in a proper manner. A system clock is also being used, that is used to produce timing signals to ensure the synchronization is taking place, and definitely if this is not working properly, the system may crash. One very important term that you need to focus on is the use of the alternate word for RAM. RAM is a term that you already are aware of, random access memory. And along with that, we are sometimes using the term IAS for it as well, which is an alternate word for RAM. Either you say RAM or you say IAS, they both mean the same. It is immediate access store. So now the one more thing that you need to focus on is IAS and RAM. Registers. Registers are basically the general purpose registers or special purpose registers, and what we will be focusing on are the special purpose registers. And they are mentioned here. What you need to know is the registers, their names and their purposes. Very, very important. So if you just recall PC and CIR, these two are present in your CPU, and they are meant to actually go for PC is holding the address of the next instruction while CIR is holding the address of the current instruction. Then we have MAR, MDR, memory address register, and memory data register. Their purposes is also mentioned here. The MAR is holding the address of the memory location currently being worked upon, currently being read from or written to. And MDR is actually the register that is containing the data that is being read from the memory or data which is about to be written to the memory. Lastly, most important one that you need to definitely focus on is accumulator, ACC, shortened as. This is the register that is holding the data that is either worked upon or after the calculation is being performed. Still, the ACC is going to hold that particular data. Worked upon data, जिसके पर काम किया जाना होता है, या जब काम किया जा चुका होता है, इन दोनों सूत्रों में accumulator is holding that data. Then you have the system buses, and in this buses, we need to know the three buses, which are address bus, data bus, and control bus. What are they doing? And before that, there's one memory that is present here. So what you need to focus on is this table. This table 3.2 is the section of the computer memory. Just remember, whatever is written in address is going to be, we can say address or location, they both mean the same. We can say contents, data, or value, they all mean the same. So you can see the addresses are being mentioned and they are contiguous, and whatever is written in under the address column is going to be held in MAR. Whatever is present under the contents column is going to be stored in MDR, memory data register, memory address register. So you may get a question that deals with something that what is in MAR and what is in MDR. So you just pay attention to the values present, and you can see for yourself that what is in MAR is this one, and whatever the contents that are present in MDR. So a question can come in your paper regarding this topic as well. Moving on to back to buses, you can see address bus. It is basically the name, as the name implies, it is carrying the addresses throughout the computer system, and it is a unidirectional bus. It is between the CPU and the memory, and it prevents the reason is the data is unidirectional. The bits are traveling in one direction only because it is going to prevent the addresses being written back, being carried back to the CPU. And that will be not a needed feature. That's why you can see address bus is unidirectional. And one more thing is the width of the buses, the type of data, the number of bits that can be transmitted is definitely going to make the performance better in the buses, in the computer system as well. Data bus is bidirectional, and as the name implies, it is allowing the data to be sent in both directions from the CPU to the memory and vice versa, as well as to and from the input and output devices. So the data bus is carrying the actual data, and again the same thing. If you are increasing the width of the address bus and the width of the data bus, definitely that will result in improving the performance of your computer system. Lastly, it's control bus, and the control bus, as the name implies, is going to perform the controlling operations. It is usually 8 bits wide, and there's no need to make it a little wider because its job is limited to carrying the signals from the controlling to all the other computer components. So as the name implies, you can remember they're working because their working is linked with their name. Very important thing is fetch, decode, execute cycle. And for that, I recommend you that you better understand this whole flow chart and you actually understand the few terms that are used here. And you can see after any instruction now is resulting in an answer of yes. What is happening is the PC is containing the address of the memory location of the next instruction. As the name implies, program counter, it is holding the address of the next instruction. After that, this address is copied from PC to MAR. So MAR is your destination, and the data is copied from PC to MAR. After that, what happens is the contents at the memory location address contained in MAR are copied temporarily to MDR. So now MDR becomes your destination, and the data is copied from MAR to MDR. Like whatever has been pointed towards is copied from to MDR from MAR. Then you can see the contents of the MDR are copied and placed into CIR. The next stage is CIR is holding the contents of the MDR. And lastly, the PC value is incremented by 1. So as the implies counter, if you recall it from your own programming, you have learned that counter normally means counting, and here it will increase by 1. The instruction is finally decoded. So decoding means understanding what the instruction is, and then it is going to be executed. And that is why it is called fetch, decode, execute cycle, FDE. Sometimes you can shorten it as FDE for our own learning. So fetch, decode, and execute cycle. I hope that is very much clear to all of you, and it's very simple. Isn't this? And now it is making your life a little easy. Okay, one more topic that is very important is dealing with the coarse cache and internal clock. So, very quick recapping of cache. If you remember, cache is basically the high-speed memory that is present to make your work a little faster. And what you need to know is the factors affecting the system performance. You can see for yourself that overall system performance can be improved if you are increasing the width of the buses, which are address bus and data bus. Remember that the control bus is 8 bits and it is not going to be increased at all because that is not needed. Second factor is overclocking. As you can see, the overclocking means that you are going to change the clock speed can be changed by altering the BIOS settings. But the problem that can happen is execution of instruction outside the design limit can lead to seriously unsynchronized operations. The computer would definitely crash because it will become unstable because you are going to make it perform the task that it can not perform at all. Overclocking can lead to serious overheating of the CPU, again leading to unreliable performance. Second factor is your overclocking. The third factor, as I said, is cache, and definitely cache is going to improve your system performance. And lastly, it's the use of cores, that is quad core and dual core that you may have heard. So what is happening here is, you can see for yourself, one core is made up of an ALU, a control unit, and registers. So if you are actually increasing the core, means that you are making it a dual core or 2 cores, what will happen is it will have more, can say, capacity to handle the operations, and definitely that will result in improving your system performance. When it comes to quad core, that means it will be having 4 cores, and you can see the diagram that shows that what are going to be the channels to which data can be transmitted. So if a question comes in the paper about the performance to be improved, so you can mention the 4 factors. As I mentioned here, increase in the bus width, which is for data bus and the address bus. Increase in the clock speed will definitely increase the speed of a computer system. It can be altered by changed by altering the bus width, the clock speed, and the use of multi-cores. And you can talk about the use of cache memory, and that will also be considered as a mean to improve your system performance. Instruction set. For this, what you need to know is the 2 terms, which are operand and opcode. And opcode is basically the opcode informs the CPU what operation needs to be done, what action you need to perform. And operand means the data on which the action is being performed. So that is why you can see operand is the data which needs to be acted on, or it can refer to a register in the memory. So what you need to know is, since the computer needs to understand the operation to be carried out, there's actually a limited number of opcode that can be used, and this is known as instruction set. So what you need to know here is the instruction set is what is instruction set and what is opcode and what is operand, and then you'll be able to answer very easily the question that is coming. If it comes in the paper, we should be able to answer. Embedded system is already being covered, so you know about the embedded system, and then you talk about the input devices and output devices. But one thing that you need to be very careful about is the use of sensors in different applications and the use of actuators when it comes to the controlling applications, the use of actuators there. When it comes to monitoring applications, there is the signal being sent to the message being sent or a signal, a siren is being rung. So this is what you need to remember in order to get good marks in your question. One important caution is कि आपने ये देखना है कि क्वेश्चन कितने मार्क्स का है, जितने मार्क्स है इसका आपको उतने ही वैलिड पॉइंट्स लिखने हैं. बी केयरफुल. Sequence should be maintained and answer as many points as the question is demanding. I'm not discussing the entire input devices or output devices, but since sensors is a very important topic that is even covered in your chapter number 6, for this reason, I just want you to know that how will you start your answering. First thing that you need to know is what kind of device is sensor. It's an input device, and that is meant to measure or read the physical properties. And this physical properties may include pressure, temperature, acidity level, and a lot of other things are also included in this. And along with that, you need to know that if I want that reading to be understood by the computer system, I need to perform a conversion, that is analog to digital conversion. And for that, I need an ADC or analog to digital converter. And the role of ADC, as you can see from the diagram, is to convert the analog signals, which are in the waveform, to digital data. And that digital data will be processed by the computer system. And in case you are performing some controlling application, controlling devices are being used, then you need to, where a motor or valve is being used, and definitely you need to convert the digital signals back to analog to perform the operation. And then the role of DAC is supposed to be mentioned. Along with that, you need to know what is digital data, what is analog data, how is it being represented, and that can also come in your paper. What else you need to know is the application of different sensors like temperature sensor, its description and the example. Similarly, moisture sensor, humidity sensor, light sensor, infrared, which is active or passive, pressure sensor, acoustic or sound sensor, gas sensor, pH, magnetic field, accelerometer, proximity sensor, flow sensor, which is mentioned here, or level sensor. So what you need to know is just simply go through these and you'll be able to get a question and you'll be able to answer that question very easily if you have actually remembered the use of different sensors and different applications. Still you have time to revise. Very important thing is this chart. Through this, you'll be able to understand what is the difference between monitoring application and controlling application. So here you can see the beginning is the same. Sensor reading are being taken. They are converted into digital from analog to digital signal using the ADC. Then we have the comparison being made. And then you can see in monitoring what happens is the new data is outside the range. A warning message is sent to a screen or an alarm is activated. And the processor has no effect on what is being monitored. It is simply watching. It is simply observing that what is in the range and what is outside the range. On the contrary, if you see the controlling application, you can see the new data is outside the range and what is being done. The use of valves is there and definitely the use of DAC in between. And the output from the system affects the next set of input. And you can see the role of feedback, which is missing from this monitoring application. So feedback, a loop is activated and the process is continued and then the readings are taken once again. So this is how we can frame a very comprehensive answer to score easily. If it's a 4-mark question, means 4 valid points, 5-mark question, 5 valid points. And remember to follow the sequence so that it is going to give a good impact on the examiner. Examples of monitoring of patient in a hospital, monitoring of intruders in a burglar alarm system, checking the temperature levels in a car engine, monitoring pollution levels in a river. As far as controlling is concerned, you can see turning street lights on at night and turning them off during the daytime, controlling the temperature in a central heating system or air conditioning system. Chemical processes are being controlled where the temperature is being maintained and our pH is going to be also maintained. And we have operation of ABS in a car and controlling the environment in a greenhouse. So these applications are being discussed here. Just read them for your own. They are very simple ones which you can easily comprehend yourself. The use of different applications, how are they being handled? And a question can come in your paper which you can answer very easily if you have read these applications just as for a reading purpose. After that, what you need to know is the you need to solve the questions on the past papers, the important ones, so you can score very easily, and you can see the marking scheme also, so that you can understand your answer, whether it is meeting the criteria or not, or is it missing something that you cannot score. Now, moving on to one of the most important topics of this chapter, that is storage. What you need to know is the difference between the two storages, which are primary storage and secondary storage, and what is coming in primary and what is coming in secondary. Primary is RAM and ROM, and secondary is internal secondary and external secondary, which you can see here. Sometimes it is mentioned external secondary, sometimes mentioned as offline as well. So whether they are using the term offline or they're using the term external secondary storage, they both mean the same. But primary is RAM and ROM. HDD, the role of HDD and the role of SSD, and then you need to know the role of DVD, CD, and DVD RAM, then Blu-ray disc, then USB memory stick. And be careful, it's USB memory stick, not USB. You will not score a single mark if you have written USB there. Or you can even write down flash memory and then removable hard drive. Moving further, what you need to know is the difference between primary storage and secondary storage. You can see directly accessible by the CPU, contains RAM and ROM, and cache memory. On the contrary, secondary storage is not accessed directly by the CPU. It's all are non-volatile devices, but as far as primary is concerned, ROM is non-volatile, but RAM is volatile. And can be external or internal to the computer. Examples include HDD, SSD, DVD, memory stick, and Blu-ray disc. What you need to know is the difference between RAM and ROM, and be cautious when it comes to differences. आपने इसमें पहले एक difference value लिखी, like जैसे for example आपसे पूछा गया ROM और RAM का difference. What you will do is you will mention ROM is non-volatile while RAM is volatile. In this manner, you will write down the points and you will be able to score 1 mark for writing down one difference between the two terms that are being discussed. Like it can be asked about ROM and RAM, it can be asked about DVD and CD. They can ask any question, but you need to learn the way of answering. That is very, very important. So what is it? RAM is going to be, from the RAM features I mentioned here. RAM is volatile, means the data is lost when the contents are lost, when the power is turned off. It can be written to a read from, and the data can be changed by the user, used to store data files, part of their application or part of the operating system currently in use. So you can even get a question that deals with the terms being asked, and you are asked to tell by looking at the definition. So this is what you need to know. The size of the RAM can be increased in the fast, and if you want to make your system work faster, then you must be increasing the size of the RAM. Then RAM is further classified into DRAM and SRAM. What is DRAM and what is SRAM? You can see the type of RAM that is refreshed is DRAM, and DRAM has a few advantages. It is less expensive, it is consuming less power, it has a higher memory capacity than SRAM. And SRAM is basically making use of flip-flop, and SRAM is faster. SRAM does not need to be refreshed, and it's a little expensive. And for that, you need to refer to this table if you really want. You can refer to this table also for the same as I discussed right now, the DRAM and the SRAM differences, and you can easily score. ROM is non-volatile. ROM is holding the data that is written by the manufacturer. User has no access to ROM, and it is sometimes used using the term ROM BIOS as well. And you can see it is showing how to start the computer system, how to boot the computer system. The same is mentioned here as I discussed right now. So you can refer to this table 3.10 for the same as well. Application of ROM and RAM. Just remember, very simple thing, whatever is the factory settings are always stored in ROM, no matter what the device is. And similarly, whatever the user is setting, whatever the user is programming is written in RAM. So simple thing to remember is RAM is holding what and ROM is holding what. Similarly, the same is applicable here. Secondary and offline storages, we have the magnetic devices, we have solid state or optical, and hard disk drive. What you need to know in hard disk drive is very simple. You need to know what is track and sector. You need to know the term platters, and you can see the tracks and sectors. The round ones are tracks, and sectors are the tracks are divided into sectors, and the data is actually residing in the sector. And sectors are meant to store a certain number of bytes, a fixed number of bytes. And the platters are, the hard disk drive will have a number of platters that are spinning about 7,000 times a second. And the read-write heads, the row of read-write heads. The row of read-write heads is they are moving forward and backward to store the data. And what is it made up of? Platters are made up of aluminum, glass, or ceramic material. And a number of read-write heads are used to read the data from and write the data to the hard drive. Then you need to know the latency term. What is latency? And then the term fragmentation, as you will study, as you have studied in chapter number 4 as well. The software, where we have talked about the utility programs, we have talked about the disk, the defragmenter. So fragmentation, you need to know this term as well, because if you are storing the data, if you are saving the data at different time intervals, then it may result in your disk being fragmented. It is possible that the data is not present as in a one go. It is not present in consecutive locations. It is broken down into different pieces, and they all are stored at different locations on your hard drive, and that results in fragmentation. Latency, as you can see, latency is on the worst situation. It can come on the screen as please wait. So sometimes you are performing a lot of operations, and that results in latency. That latency is defined as the time it takes for a block of data on a data track to rotate around to the read-write head. And in some situations, I may get a message that not responding. And what happens is it causes a lot of activities are being performed, and the HDD is not able to handle all those activities, and it may result in a message as not responding. Along with that, you need to know the role of removable hard drive. That what are they? They are actually the external secondary storage devices that are meant to store the data permanently, which you can utilize for the secondary for the backup. SSDs. SSDs, as the name implies, is solid state drive, and these are making your life easy because they are removing the problem of your latency. And you can see they don't rely on magnetic properties. The most important type of SSD is your storing the data by controlling the movement of electron within NAND or NOR chip. So you need to know the working of your SSDs a little bit. What is it based on? A little bit of it you need to know, and then you need to know the benefits of SSD over your hard drive. More reliable because no moving parts are being used, considerably lighter, they don't have to get up to speed to work, they have a lower power consumption, they run much cooler, and because of no moving parts, they are very thin and data access faster than your hard disk drive. Although the problem with SSD is your SSD endurance. The life is not very much, and that is a very big problem with SSDs, and that is why they're not used on the servers. Then you need to know the memory stick or flash memories. What are they meant for? What are they making our life easy by using by storing the expert system on it? Lastly, we need to know the optical media. Optical media, CD, DVD. You may be asked about the differences and the similarities between CDs and DVDs, the way I talked about in the beginning. CD is using single layering, while DVD is using dual layering. And definitely with this dual layering, what happens is it can store more data as compared to the CDs. Then it comes to Blu-ray disc. As the name implies, it is using the blue laser, and it is going to be much more, can say, popular because it is storing much more data, and the access rate is a little faster. And they are going to take up the CDs and DVDs in near future. You can see the differences are being mentioned. The main difference is the blue laser is being used rather than a red laser. Using blue laser means that the pits and the lands can be much smaller. Consequently, the Blu-rays can store more data. You can see 5 times more data than the normal DVDs. Single layer Blu-ray disc uses a 3 to 1.2 millimeters thick polycarbonate disc. However, dual layer Blu-ray disc and normal DVDs are using a sandwich of 2.6 millimeter thick discs. Blu-ray disc automatically comes with a secure encryption system that helps to prevent piracy and copyright infringements. The data transfer rate for DVD is 10 megabits per second, and for a Blu-ray, 36 megabits per second. So you can see this is a great difference between the data transfer rates. So you may get a question, and you may be able to answer very easily if you have actually remembered these simple points. I suggest you that you go through this table so that you can actually recall the differences and the similarities between the different devices. Then virtual memory, as the name implies, what is virtual memory? What you need to see is if there is no virtual memory, then what may go wrong. Maybe some applications are not getting chance to store the data in the memory, and that may result in some problem. And on the contrary, if you have virtual memory, then that problem is resolved to a certain extent, because whatever data that was saved earlier will be out of the memory, and then you can use the empty space of your hard drive to be used as the memory, and that is what is given the name virtual memory. After that, what you need to know is the cloud storage, the types of cloud, why the use of cloud, the public cloud, the private cloud, and the hybrid cloud. Public cloud is a storage environment where the customer and the client are different companies. Private cloud, what is it? And then hybrid cloud, a combination of the above. And what is the advantage? You can see the drawbacks and the advantage, and the drawbacks and the advantages are very important. You can see customer files are stored on the cloud, can be accessed anytime, anywhere. There is no need for a customer or client to carry an external storage device with them, or even use the same computer system to store and retrieve information. The cloud provides the user with a remote backup of data with obvious benefits of the data, like we are relieved of the data loss and the data disaster recovery methods. The customer client is a failure of the hard drive, they can actually retrieve the data from the cloud. The cloud system offers almost unlimited storage capacity. I mean, on the contrary, if you just see the customer has a slow or unstable internet connection, he will not be able to access anything from the cloud. Cost can be high in case if you are going for a higher capacity, then you have to pay a certain amount to your ISPs. And potential failure of the cloud storage may result in a complete failure for your own data and for your own system. So everything has its own benefits and drawbacks. So you need to work on this one as well. After that, you need to know the NIC, as I talked about in this chapter. As I talked about this material in your chapter number 1, the use of hexadecimal system, the same is being discussed. Only a change is here you are told about the types of MAC addresses, which are UAA and LAA, and UAA is the most common one that is going to be said by the manufacturer, not changed. And on the contrary, there are some situations where we get asked to change the MAC address, and that is called LAA, or locally administered MAC addresses. IP addresses, as we discussed earlier, the same is mentioned here, but then we need to know the MAC address and IP address differences that can come in your paper. The same as I discussed earlier, you can see identify the physical address unique for devices on the network assigned by the manufacturer. They can be universal or local. You can see the 48 bits and the 64 bits. And on the contrary, you can see is the global address on the internet may not necessarily be unique. It is possible that IP addresses can be same, dynamic IP and static IP. And then you need to know the routing operations are being done in 32 bits or 128 bits. 32 bits is IPv4 and 128 bits is IPv6. Along with that, you need to work on the static IP or the dynamic IP. As you can see here, the static IP means the one that is fixed and it remains same. On the contrary, we do have dynamic IPs which can be changed, and definitely this is assigned to the person when he is logged on, and the moment he logs off, it is going to be given to some other person. And the differences are mentioned here. The dynamic IP and IP and static IP addresses are being mentioned here. Go through them and then you'll be able to remember. Routers, again discussed in chapter number 2, where we talked about the data packets. So same thing is being discussed here, what the role of router is, and it is simple to remember. Routers are intelligent devices that are meant to know the best possible path to reach the destination. So in this manner, you will be able to understand and revise the whole chapter number 3. Best of luck. Allah Hafiz.